Hello everyone. Let's see the third problem, beautiful subgrids. This is also a bit bit set problem. Like we have to use bit set to optimize our solution. Let's see. First read the problem. You are given an n cross n grid whose square is either black or white. A subgrid is called beautiful if its height and width is at least 2 and all of its corners are black. How many beautiful subgrids are there within the given grid? 1 means that the square is black and 0 means it is white. And now here n is up to 3000 only. And so let's see first how to do it using brute force. We have to indeed use O of n square. We have to do in O of n square. But if you try to do without any optimization, then it will be of n cube. Let's now we have to count the number of rectangles which can be formed. First, let's see sample. This, if you pick this one, like this rectangle, then all the corners are black, or this one, then also. So we have to count these rectangles. Now, a rectangle is will be it will only when it is kind of we have to pick different row and two different columns, and these corners should be black. So let's suppose we pick two a row I and j. We know that these row I and j, and these are some written over there, like the number written over there, 1, 0, and 1 type, and similarly in here also. Now, what is the what is the count of rectangles that we can generate using only these row I and j? So the number would be equal to, we have like basically, if we pick this one like two column, then this bit and this bit should be same. This bit and this bit should be same and 1 equal to 1, and similarly this is also equals to 1. So you can see that this is indeed equals to, if let's take 1, like 0 0 1 1 0, and 1 0 0 1 and 0 here. Let's suppose here 1 also. So in here, oh, take the end of both binary string. So this will equals to 1 0 1 1 and 0. Now in count the number of ones in this binary string, which is 3. Now out of 3, you are having 3 positions where both the bits, like where the bits in both string are is equals to 1, are equals to 1. So you have to like we have to pick out of these 3, we have to choose two ones, like two positions. If you choose two position, then it will form a rectangle. So the count will be equals to 3c 2. So the answer is basically for I and j, for two row I and j, the count will be equals to the end of number of set bits in binary string I and binary string j. Number of set bits in this. This is a logical and. Now we this is now if we do this manually, then it will take off n complexity. We If we count number of set bits b bi and bj, then it will take off n complexity. So we have to use bit set. We have to use bit set, which solve uh, which basically we whose length can be up to 3000. It can be, its size is unlimited. Like you can make a bit set of size 3000 also, and you can do all the operation that we can do with integers. So if bi is a bit set and bj is also bit set, then if you take end and count the number of set bits, it all can be done in of length divided by up to 32 or 64. So the complexity is basically of n cube divided by 62 of n cube divided by 32. So this can be, this will pass. So this is going to pass in this case. Now let's see the code. Don't know how to use bitset, just google it. It is similar to like using vector also. So I am taking the input n, and basically first maximum can be up to 3000, and I am creating a array of bit set. So there can be up to 3000 number, and each number can have up to 3000 length. So what this intersection counts? This intersection counts the number of set bits in xi and xj. So this is dot count is a function which counts the number of set bits in xi and xj. So this is a function which will convert the string s into, which will assign like initialize xi with string s. Now I am iterating over all I and j, counting the number of intersection of I and j like xi and xj, and adding the answer with c into c minus 1 divided by 2, which is basically I am choosing, yeah, I am taking this one. I am doing this thing here. If the number of set bits, like if the number of set bits is x, then the answer will added will be xc2. Now yeah, this is fine. And one thing you have to do is basically add this flag also, like this optimization, which will like optimize your code, and you now you can submit it and it will pass. Thank you.